Hi there. This is Intro to Malloc Exercise 1 Solution. I think this visual that we have on screen really says it all. The diagram on the right side has all of the chunks in order in memory how they're actually allocated. So we have previous, we have current, and we have filler. From reading the code, from reading the start.py diagrams, from reading this, it should be pretty obvious that the size of the allocation is hex 110. And that's all we need to do. The size is just 110. So I can then show that to you in the terminal. We go to start.py, we have that one to do. We can change this to 110. And now if we run that, we do continue. And then we do the corruption point. And now we look at it, we can see that there's actually there's 4 chunks here. Unlike in the previous video when we corrupted and there wasn't. So now if we do continue again, we can see, hooray, the chunks are okay, we did it. The goal of this exercise wasn't to challenge you, it was really to make sure you understand how chunks work and play around with the tool some. If you haven't played with the viz heap chunks, heap, and all those commands yet, I think it is really helpful. Ponybug does offer a lot of functionality. Now, if you do want something a little more interesting, we can make this more interesting. See, this free I thought was a little bit too hard, but we can uncomment it out. So it's there. Call make and have that free happen. And now, if we do start.py, we execute this, it'll work fine. But the interesting thing is now when we actually call this, maybe I need to go to the next step. Yeah, so this first chunk was freed, which means that it's actually stored somewhere, which is kind of cool. We can see that it has an FD and a BK pointer that it's showing us. And although this is kind of the next exercise, if we type in bins, we can see the different types of linked lists that we're dealing with. And this one happens to be in the unsorted bin. Don't need to know that right now, but does that work? Okay. Anyway, so we can see that that chunk is free. And when we free our chunk, it ends up being fine. And you're like, but Max, why is it fine? The 1 is there, but the previous chunk is actually free. And it's actually fine to have that happen. It's not okay to have it be free and not be able to go backwards correctly. So right now we have the preview use bit set to 1. But if I set it to 0, it's something entirely different happens. So we're going to check out the heap here. And this works out, it looks fine, it looks pretty normal so far. But if we continue, then we're actually going to get a seg fault. Why are we getting a seg fault? So this is a nice thing, is it actually shows the source code for Malloc. This is the line 4004 is actually where it crashes at. And the reason it's crashing is because when we try to combine the 2 chunks together in a process consolidation, which we'll talk about later, it doesn't have the pointers there. And so it's just going to go kablooey. So if we want to make this work, we need to make sure that the prev size is done correctly. If we do hex A0 and we run it now, if we do heap, this is before our chunk gets freed, but it's just good to see that the size is A0. Size of this one is 110 because the previous chunk is free. And then when we do continue, everything works out just like we wanted. So it means that the heap was totally fine. It added the 2 chunks together. We did okay. So that is the exercise. If you have questions about that, feel free to put them on the GitHub. Maybe I'll make a Discord. I'm not really sure yet. But good job on that. That's your first exercise and first hands-on thing in heap exploitation. Hack the planet.